Hello, everyone, and welcome to today's webinar on efficient and sustainable trail design with RoadEng. My name is Patricia. I am an account manager and the LATAM business lead here at Softtree. And joining me here today is our training manager, Matthew Dickey, who will be leading the live demonstration. So let's see our agenda for today. We will do a brief introduction to RoadEng for trails, and then Matt will show you in a live demonstration first how to import topographic data to build a 3D terrain model. Then he will use Path Explorer to find the optimal initial trail location considering max grade and another constraints. And then we will switch into location to model the trail corridor. In location, we will show you how to adjust cross-section geometries, optimize our vertical alignment, and make micro adjustments manually to the design to ensure the trail is well suited to our project needs. So let's start with some commonalities between trail and road design. So there's definitely some similarities there. Both trails and roads can be designed as alignments in RoadEng, and we're going to show you how to do that in today's webinar. In both cases, optimizing the alignment can help reduce costs and minimize the environmental impact. And of course, there is some key differences too. And these differences play a big role in how we use our tools and what we need to consider during the design. For example, compared to roads, trails focus on the route, not the destination. Trails also allows for tighter vertical and horizontal curves, meaning that we can afford to wiggle around more to achieve a lighter touch on the landscape. They also allow narrower prisms, allowing the trail to fit between obstacles, like for example, individual trees, something that it is not often practical for road projects. Another difference is that trails can work with weaker prisms. Unlike roads, trails are typically unpaved and may have little or no surfacing material at all. And finally, since trails have limited access to maintenance equipment, it is crucial to consider how the trail interacts with the surrounding terrain. So carefully planning and design are really essential to manage erosion risks and ensure the long-term sustainability of our trails. And that's enough of me talking. Let's see some action. I'm going to hand it over to Matt, who will walk you through a live demonstration and show you how to use these tools to address considerations with a quick example project. Over to you, Matt. Thank you.
All right, perfect. So as promised, we're going to run through an example. Some things will be very similar to what those of you that attend our road design webinars will be very similar to that, but I'll try and pay extra attention to the things that are different and explain kind of what's going on there. So to start, I'm going to start in terrain. And I guess before we forget here too, if you do have questions, feel free to type them out in the questions dialogue, and we'll either answer them at the end or try to answer them if there's any lulls while the computer thinks. Yeah, so I'm going to run through terrain and dump in our spatial data, get a feel for what's going on with the project, and then later we'll move into location where we'll really model it as a proper corridor. All right. So I'm going to, in terrain, insert my spatial data. So my survey data for this one is LiDAR data. We'll bring that in. And we're going to turn it into a surface. So we'll click terrain modeling. We'll click generate. And there we are. We can click our 3D view. We can see what's going on and what we're dealing with. Now we can also bring in other spatial information if we'd like. And so here I'm going to bring in just a shapefile to add a little bit of context for our project. So here we've got a couple existing trails on the property, and my project, what I'd like to do is I'd like to create a loop trail that goes from, say, here around the upper portion of the ridge, comes back and ties in with this existing trail that's on site. Now with this, if we were to, I'll just create a new feature here. If we were to tell the software that we want to find the cheapest route from there to there, well, it's probably not going to make that big loop that goes around and captures all these kind of micro sites and points of interest that we'd like to make sure we go through. So for that, if we're using Path Explorer on a trail project, we're probably not looking at it as just in terms of the start point and the end point for our destination. We might not want the most efficient way to get there, and instead we want to make sure we hit the interesting parts along our route, but we save some money on how to get to those interesting parts. So for this, I'm going to just bring in a couple other shapefiles here. And we'll make these a little easier to see for folks. So yeah, rather than going from here to here, we're going to kind of guide it, and I'd like to have, well, make sure I make it somewhere handy to the top of the hill here. I'd like to have a lookout over the ridge here. That's a decent point to have a view over the ocean, and then we'll come back along the bottom. So rather than A to B, it's going to be A to B, B to C, etc. Now for this, and like a road, we also want to be cognizant of what's going on with our drainage parameters. So I'm going to click hydrology tools, and I'd like to get a feel for if we expect there's any flow paths or ponding that we'd like to be cognizant of. And here we're on a ridge, so water is not a huge driver of our design, but we will want to account for it. Now I'm going to start here, and I'm going to talk about setting this up before I actually do it. And Patricia covered it in the intro. There's a lot of flexibility to move things around with trails. And we want to make sure our design constraints reflect that. So we'll typically see, in terms of things like radius constraints, smaller values in trails compared to roads. And we want to be cognizant of our whole project and how we're going to build this thing. So for this one, I'm going to go with a minimum radius of 10. So it's going to make sure we can get a little wagon around there with a trailer for actually constructing this. Now we're going to have a much smaller prism than we normally would with a road. And the big one here that's going to make this take a little longer than what we'd expect with a road is reducing our resolution. So with the trail, it's well, as introduced, we can avoid little obstacles and kind of thread the needle through obstacles. So we're going to reduce our resolution down to make it sure we're capturing something that works well with our horizontal radius and also captures those little details that we can make adjustments for easier with a trail. Because we do make the problem larger by using these small values in terms of computing power, I am probably going to use a area of interest to help, well, speed this up. So if I know I don't want my trail to go anywhere outside of this line here, there's no point in even considering those options in our solution. So we'll go with that. And now this time, instead of just talking about setting up, I will set it up and we will run our Path Explorer run. So here, I'm going to say 10-meter radius. I'll go with the 2-meter horizontal resolution. I'm going to keep my vertical resolution at medium. I'm going to, well, as introduced, adjust my road width to not be something super wide that defaults to a road prism parameter. And I'm going to set my design grades to be whatever I'd like. Now, just like when we're doing a road, the costs and what we're trying to minimize is earthworks costs. So I can use whatever I'd like here for my cut and fill costs. And I can add in other parameters to account for other things. So my streams, there are a few here. So I'm going to add those in as polylines. And we'll select these. So we'll grab those, and I'm going to say each stream is, I don't know, $1,500 to cross. And that area of interest that we brought in, well, I'm going to add that in as a no-go polyline. And there, so we won't be allowed to go outside of that. And here, I want to, well, I'm going to use this existing trail, so I want to make sure I'm starting off kind of pointed away from it. And as I come into this next point, I want to be cognizant of my approach direction here. And that's going to set it up so we can have this nice continuous line as we go through and we do a few of these. So we'll hit run. It's going to think. And well, now it's told us we found 5 possible solutions. We'll let it run for a little bit longer here, and eventually it's going to say unlikely to improve further. And once it does that, we'll hit cancel. And while that thinks, oh, and I guess there we are. So I'll hit cancel here. We can see we've got a few routes right on top of each other, and I'm not surprised that these are on top of each other, just because, well, cheap solution is pretty close to a straight path here. And we'll run another one of these. Again, kind of that A to B, B to C aspect of things. And when I do it this time, well, I don't want to delete these points that I've already run. So I'm going to uncheck this box. For my approach directions, I want to, well, have something that largely is continuous there. So we'll hit OK. We'll hit run, and we will let this thing run again. And while this thinks, I will answer a couple questions.
Okay, we have one, Matt, already. Okay. The question says, can I import an AOI from GIS?
Yep. So for that, just like I brought in my shape files for the my points of interest, we can bring in a shape, we can bring in a KML, DWG, etc. So we can bring in your vector data from kind of all the standard formats. Yeah, and I just drew it in because I didn't already have that existing in another format. And this is unlikely to improve further. So we'll hit cancel and we'll see what we've got here. All right, so here it's a little bit more interesting. So the roots aren't right on top of each other. We can see they're wiggling around. And if we were curious which one of these is going to be the expected cheapest, we can highlight them. We can click select by name, and we can see, well, we've got a few I'm going to deselect this one here. So this green one here is expected to be our cheapest. We could continue along for the remainder. It won't take long, but it will seem repetitive. So for the sake of having you guys watch my screen, I will jump ahead to something that I've already run here. Yeah, so if we repeated that process for all of those points, we'd end up with something like this, and I'd go through and we'd select by name. I'm gonna turn that one off here. I'll get rid of the ones I'm not really interested in. And we don't have to delete them, but I'm gonna do it just because it's a little easier for people to see. So I've got that. And we'll go select by name. Again, we can narrow it in on just being the cheapest one. And once we're happy with that, we can hit Shift, select the features that we'd like to turn into our single alignment, and we can right click, modify, join, and away we go. Now again, just to save a little bit of clicking around and not making you watch the process be repeated a few times here. I've got one that's already selected, and we can use this for our example. Yeah, and just as a bit of a recap for where we've at, we've brought in our LiDAR data, modeled our topography. We've added in extra data that we'd like to consider, so streams in this case. We've run Path Explorer for, well, from point A to point B to point C. And while we're doing that, we've added some direction constraints as we come into those destinations or leave those points of interest, just so we get something that's nice and continuous. And once we're happy with this, we will switch over and open up location, and we will do our design in more detail. So instead of considering this as a line on the map, we will consider it as a proper corridor. So I'm selecting that terrain file that has my Path Explorer features that have been connected or joined. I'm going to use that Path Explorer feature as my initial alignment. And we're going to click done. And it's going to take a moment and read in. So to start, we've got that same Path Explorer solution showing up. We've got our profile, we've got our 3D view, and we've got our section view. And if we'd like, we can add in backgrounds as well if we'd like to have a little extra context for what's going on here. I'll grab an image that I've already got. So with this, we're gonna start designing, and there's a few things that we can tackle first. But for this one, I am going to take this polyline, and I'm going to turn it into a proper alignment with curves and tangents. So I'll come up to corridors, I'll hit operations, I'll click polyline to alignment, and I'll set my radius. I'll set my max offset distance. And we'll let this run. Now with this, it's going to try and reduce the number of IPs, so the number of curves to stay within that tolerance. And here I suspect this won't actually get below that 2 meter mark. And in this case, cases like this, where when I ran my A to B and B to C, I didn't just have it going perpendicular to each other. I've allowed it to kind of deviate a little bit more. So it'll still try to reduce that, but it's probably not going to stay underneath that limit. And but it'll still largely comply with what we're looking for. So there we are. So we've got a proper alignment with curves and tangents. Next item, and it's a big one. Well, we probably don't want to have a full road. So here I've got my road width. My default prism is set at 6 meters, which is totally overkill for what I'd like. So we'll go up to our templates, and we're going to make something that's a little more low profile. So I'm going to use my resource low volume road as my, I guess, my starting point. But for this, I'm going to go onto the eLibrary, and I'm going to use some other template components to take care of some geometry. So instead of using my resource one component, I'm going to remove that. I'm going to open up my roadway components. I'm going to go in here. I've got this resource 2, and here I would like to have my alignment automatically outslope for me. So with this, I'm going to set my crown, and we'll be generous with our crown just to make sure the water is getting moved away. I'm going to open this up, and here we don't want an 8 meter wide road. We don't need a shoulder. So I'll remove the shoulder. I'm going to say, well, I'll go with 1.5 meters here. We want to have room to build what we'd like to build. I don't need 45 centimeters of surfacing material. And we probably don't need 2 different specs for that surfacing material as well. So I'm just going to go 10 centimeters of surfacing material here. And I'm content. I'm going to hit copy. I'm going to hit paste as right. And here, I also probably don't really want a ditch. So it's narrow enough, I'm outsloped. I'm going to try and get the water to just cross this as needed. So I could remove my ditch component altogether. I'm going to set it as a 0 width and depth though. We'll hit paste as right. And I'm happy with my slopes. So I'll hit OK here. And we'll assign this new template to the length of our trail. All right. So we've got this much lower profile prism. And next, let's actually run our vertical optimization. So right now, our alignment is just set on the ground. We're going to go in here, and we're going to make a few changes. So I'm going to just tell my sample spacing for this. I'm going to use my grades, and here I'm going to go a little steeper than what I used in Path Explorer. So I'm going to allow it to steepen things up to 12% here. Now my curvature, I want to go tight, so I can have really abrupt undulations in this. So I'll go K's of 0.5. We'll add control points if there's anywhere we'd like to be at a specific elevation. So I want to be at specific elevations at my start and my end. And we'll hit process, and another parameter that I would change for trails that I probably wouldn't change if I was doing a road is this VIP reduction tolerance. So in smart curves, we remove some curves that have a very low cost associated with them to help reduce the number of insignificant curves in the model. Now, what's insignificant for a trail is different than what's insignificant for a road. So here I'm going to reduce this down to, say, 0.2. We'll hit process, and we'll let this thing think. And we have a moment for a question or two here while this runs through and does its sampling.
Fantastic. Thank you, Matt. Let's go with one that I was reading just right now. It says, what is the density of the terrain points in the LiDAR scan you're working with?
All right. So the LiDAR scan that I'm working with, I have no idea. But we can, once this is done thinking, we can pop it open and get a feel for what that is. Now the data I'm working with is publicly available data, and the LiDAR scan is classified. So I only brought in my ground points. I wasn't really interested in anything else. But yeah, let's. So let's see here. So I've just created a boundary around my surface. So I've got a area of 91 hectares, and in that I've got about 1 million points. So 1 million ground points. There would have been a lot more canopy points before the data was classified.
Awesome.
Yeah. All right. So I've got a vertical alignment here. So we'll kind of zoom in here. We can see what we're dealing with. We can, well, at a glance, we can see we've got our mass haul is very small, so only moving 17 cubes here. If we look at the 3D view, it should, well, largely confirm what we're dealing with. And here I've got some surfacing on that. If we want to, well, see what that looks like with just our subgrade, we certainly can do that as well. And we'll see that we're really splitting the difference, about half in cut, half in fill. So very small, minor material movements to build out that prism. We can come along here and we can see, well, it's largely pretty easy to build, but then we get out here and we've got this. So there is one fairly challenging part. But we're not stuck with it either. So we can run the analysis, and we've used this as a hard point that we want to go through, but it could be a matter of we see something like this and maybe we decide to go an easier way with it. So maybe we decide we want to go 850 to 1057 and cut off that point that we were using as a point of interest. So here we can make those adjustments. And we can hit OK. So I've gotten rid of it. We can add some curves back in. And yeah, we are totally not stuck with something just because we've optimized it. Let's move that over here. So we can make manual adjustments as needed, and we could re-optimize, or if we don't want to do manual adjustments, we could redo our Path Explorer exercise from that point to go back to there. Now with all of this, of course, we did change things. We could make manual adjustments to our vertical, or we could just rerun the vertical optimization again. So with that, I'll let this thing run and we'll open up another question, and then I'll talk a little bit more of some other kind of more trail specific aspects.
Okay. Next question, Matt. How can I ensure my trail passes close to interesting points, such as waterfalls, viewpoints, or historic cultural features?
Yeah, so with that, when I ran the Path Explorer tool, these points that I ran kind of A to B, B to C, those are representing my interesting points. So in this case, when I ran this, I had them set up to, well, mainly be points where I thought there'd be a decent view. And then here in this case, well, it doesn't really make sense to have this as part of the loop. It's expensive to get over there because we needed that kind of excessive switchback to get back and keep it continuous. So here, if we want to have still access that point, we could just add in another alignment and have it connect in as a spur off of our main loop trail. So,
awesome.
Yeah. Okay. All right. And I'm going to do another thing here. So another kind of common trail aspect is culverts are a much less common tool in the toolbox for trails. So here, if we want, and let's go back to, so I've got a pretty long stretch here where my trail is descending. If I want to help break that up and allow some flow across to the prism, we could force a grade reversal. So for this one, we could do our vertical optimization, get everything kind of exactly where we think it should be, or where we would generally like it to be. And then we can come in here and we can say, well, let's make a little adjustment to things. So we're going to tighten up that curve. We're going to tighten up this curve here. And we can pull this down. And we can force that grade reversal to help move water. So it's not going all the way from up top here, all the way down. It's going to hit this point. We've got that little bit of an uphill. There's no ditch here, and it's going to be trained across the prism. With this as well, if we wanted to, we can make little adjustments to bump this into the hill in the horizontal, just the same as we made other little micro adjustments. Yeah, so if you're worried about a grade reversal, you can totally just do them, and away you go. Now you don't always have to do that, and I'm gonna cruise around here. So at this point, we don't have this really low profile prism where we want to move stuff over. We've got a little bit of a natural channel here. And in this case, well, maybe it makes sense to just add in a culvert, as we usually would if it were a road. It doesn't have to be a circular pipe, though. We could do just a simple rectangular box. And so we'll go 0.5 meter by 1.5 meters. We can put that in there, and there we are. And I've got this one hung. We could set it to match the crossfall of my ground as well, if I'd like to do it that way. Or we could add in a bridge template if it was something that we planned to properly span. Yeah, so it's super flexible. You can use the optimization tools to really help hone in and reduce those costs. Make sure you're choosing an efficient place to put things. You can use the vertical optimization to, again, well, kind of the same thing, but make sure you're moving a very little amount of material. You can reduce your volume estimates if you'd like to look at your volumes. And then once you're happy with what you've designed, you can go over to our multi-plot editor and I'll set this up however you wish. So in this case, I'll go with a book layout that I've already got set up. So we've got our plan over profile, and I've got lots of cross sections here, probably too many cross sections, so we can certainly adjust that to be whatever we'd like. So I won't go every 5 meters, let's do every 25 meters. So that is a pretty typical workflow. You can spend a lot of time diving into different nuances for those cross sections if you'd like. And we mentioned it in the start. With this, you can consider a lot of details that are kind of impractical or very difficult to consider efficiently with other ways. So I've run through a quick example. Well, it's the same example, but instead of using just streams as my construction zone, I've added in a bunch of points to represent individual trees. And I've taken those individual points in Path Explorer, I've added them in here. I've added a cost associated with them. So I've said that each tree is going to cost me $500 if I have to knock it down. And I did that rather than a hard constraint because, well, this trail is in the forest. There might be some that we have to remove if we want to maintain our design constraints. But yeah, the software is smart. It's going to wiggle around considering everything that we've told it to consider and really try to avoid those negative interactions that we have set. So with that, that's kind of my spiel, what I was hoping to cover.
Nice. Thank you, Matt. We have a few more questions here, if you want to keep going. And I think this one is related to the trees. How did you obtain your 3 points?
Okay. Yeah, so this one was something that I hadn't done before. I had a canopy height model, and you could create the canopy height model in Terrain. This one was publicly available when I got the LiDAR data, and I threw it into a free GIS tool to extract the local maxima points. So, and then I've just narrowed them down to only include trees of a certain height. So yeah, the process took maybe 10 minutes, and yeah, it's certainly better than guessing, and way better than having to map out all those individual trees by hand.
Awesome. Yeah. Okay, next question. It says, how does RoadEng handle complex terrain features such as hills, rocks, water crossings, and when designing trails?
All right, so the software itself is very smart, and just even without considering a bunch of extra details that you've assigned, it'll usually account for terrain irregularities that are difficult to build on without telling it to account for them, especially. So with this, Path Explorer is, well, it uses a simplified cross-section. So it's not just looking at it as a line on a map. It is looking at it as terms of this cross-section interacting with the terrain. And yeah, if you're on a steep slide slope, well, it's going to get really expensive to build there because your cuts and fills extend out so far. So it'll avoid those. Now, if you have other complexities that aren't just geometry related, you can add them in as construction zones. So if it was something like, I don't know, a swamp or something like that, well, not a swamp because we probably account for that with the hydrology tools, but let's say shallow bedrock on a planar surface, we could isolate that, add it in this construction zone that's going to cost more, and the software Path Explorer will avoid it. Now, if we're looking at it in terms of location, we can add in those subsurface conditions in here and assign a higher cost for those horizons as well.
Excellent. Thank you, Matt. Next question. What are the minimum specs for a computer to be able to run this software? Do I need a lot of RAM?
I'm gonna fumble this one. I think our minimum specs recommended for working with LiDAR data are like 8 gigs of RAM. It's one of those things that the more RAM, the better. The more computer performance you have, the better. So the faster it'll be. For context, I'm running 16 gigs of RAM, and I spend lots of time showing off the software in yeah, and it's more than enough RAM for most projects.
Excellent. Thank you. We have one more, and if anybody else have more questions, please feel free to use the GoToWebinar panel and send your questions there. If we don't have enough time to reply, we will send individual responses via email. And I think I'm going to do the last question, Matt. We probably close here. It says, when it comes to trail sustainability, are there any design guidelines or features in RoadEng that help with this?
Yeah, so the trail stability or sustainability, it really does complement that aspect of things. It is the software will do whatever you'll tell it to do. So as we're setting up our design specs for our vertical optimization, we can assign your minimum maximum grades, and it'll account for that. So usually those standards that you're using are set up to help minimize your environmental footprint. Aside from just dealing with the standards, though, by optimizing, we're reducing construction costs, which, well, generally construction costs it's directly linked to how much energy is used on building the project. So we're reducing the carbon footprint of actually building it. Two, by minimizing your earthworks, we're effectively minimizing the disturbance area. So if we had more cut, well, we have to cut more of an area to generate that. So we're minimizing that. And really, especially with like Path Explorer and that like individual tree aspect of things, we're allowing users to consider a lot more efficiently. So yeah, they're taking into account all these little details, and instead of guessing whether they've got it in the right spot, they can be sure they've crossed their T's and dotted their I's.
Perfect. Thank you, Matt. Do you want to squeeze a last one that I think it's interesting? I really like this question. Can you get a bill of quantities for materials and culverts?
Yep. So
it's a good one.
Yeah, I've got my volumes here. So, and I've got them set, and I can come down to the bottom and see what I'm dealing with for my cut and fill quantities. Now on this one, I do have a surfacing layer included. So I've got 500 cubes of gravel for that, well, 10 centimeter lift. If we changed it, everything would update. And then my culverts, well, I've only got that one culvert in here, but we could set up another data table to quickly account for that. So let's go, we'll turn these off. Culvert insertion points. I want to see the station. And what do we want to include here? Culvert height and culvert width, just since it's a box culvert rather than a round. So yeah, we can produce that. We can include that in our documentation as well if you want to include it right on the drawing. So this one, I've got my volumes summarized over here, and yeah, it could be your pipes, etc. Cool.
Fantastic. Thank you very much, Matt. So thank you everyone for joining our webinar, for the nice comments in the question section. And yeah, we hope to see you around.
Cool. Thanks, everyone.